Hello folks, welcome to my YouTube channel. I'm Praj, and in today's video, we are going to run multiple experiments to see how different Airflow configurations impact task execution performance. We'll be using a dynamically mapped DAG with 100 tasks that simply prints out a value, while we'll be playing around with Kubernetes Executor, CeleryExecutor to see how each of them have an impact on task executions. While we are looking at different executors, we will tweak a few of the parameters available in Airflow, especially those which can have an impact on performance. Taking a step back and looking at executors again, the executor you choose will determine how and where your Airflow task would run. Taking a step back and looking at executors again, the executor you choose will determine how and where your Airflow task would run. As executor determines the infrastructure as well as the scaling mechanism that you can achieve for your DAG performance, it plays a huge role in scaling process of DAGs. I'm not going to go too deep into different types of executors in this video. Instead, we'll look at only two of them, which is CeleryExecutor, Kubernetes Executor. So looking at the experiments that we are going to run, starting with the Kubernetes Executor with image caching, then moving on towards like using the Kubernetes Executor without image caching, and then CeleryExecutor with default settings. So for doing that, as we had like a DAG earlier, let me open that up again. Easy. Okay, so taking a look at this DAG, all we are doing over here is like the first task just generates a bunch of numbers, which gets passed on to the second task, just like adds one to it, and the last task sums it up after the second task runs. So this task is actually acting as the so for the second task we are using an Airflow's like feature called dynamic task mapping, which allows us to run like the same task with like a multiple set of parameters that we are passing over here. So for the Kubernetes operator, let's just run this task again. I'm switching over to the UI now because we already have everything set up. Let me go in here. Just going to start. So I triggered this DAG run, and I'm going to like take a look at how long does add one take to complete, because that's the longest running task out of all these three, which would have the biggest impact on the time that DAG takes to run. The last successful run seems to be going on for 6 minutes, so I guess like I'm expecting it to take around 6 minutes. So it seems like this DAG run completed in around 6 minutes, which is what we expected. If we look at our Grafana dashboard, we can see that it's nearly the same time based on what Airflow reported to Prometheus. Okay, so now what we are going to do is change the image policy to be always pull. That's actually going to throw all the metrics off, because over here we are now like trying to simulate the worst case scenario that can happen in Kubernetes. So the only case in which this can happen in production is if you have like a bunch of nodes, and for some reason each of your pod gets scheduled on a separate node each and every time. And because of the due to this, what's going to happen is they will like your container won't be cached on any of the node, and your performance is just going to be like very bad. So for doing that, let's head on to the Airflow values file, and over there under images, under pod template, we have to change the pull policy to be always, And the reason I know this is because like if you take a look at what the pod template actually does in the Helm chart. So what I'm going to search for is Helm chart pod templates airflow, and that actually brings me to this page. And if I take a look at what the image pull policy is configured in here, image pull policy, it takes values from like dot values, which would essentially just mean that it's the values file that we pass in. Under the images object, there would be an airflow object which would have pull policy, but this seems to be for Kerberos in it, which is not what we are intending to change. What we want to target is the containers. Now in here you can see that it's actually pulling from images pod template pull policy, which when we go back to our like Vim file, we can see that it's here, and that's what we changed. Now to apply this, what we have to go back to our command line and then do like a helm upgrade command and pass in the airflow values file. This generally takes like a couple of minutes to complete, so I'm just going to pause the video and resume once this is done. So this has completed now. What we are going to do next is just trigger another run for airflow, and oops, it seems the apply actually broke my tunnel. I'm going to start port forwarding again and load this page. It takes me back to admin. Oh, here we go. Whoops. I triggered another run, and like the last one took like nearly 6 minutes. I would expect this to take longer, and this is always the case with Kubernetes Executor. It's great when you have like you want to keep all your dependencies separate. You don't want to mix them, and you already have a container that's running. So for example, if you use any different language like Elixir or Go, Rust, instead of trying to add all your Rust libraries to your Airflow containers, what you could do is create a new container and just tell the Kubernetes Executor to use that container. Basically similar to the way you would do for like Kubernetes pod operator. I'm going to pause this video again, grab some coffee and be back. It seems like this is going to take even longer than 6 minutes. To be honest, I don't know how long it would take. So let's see after this run completes. Looking at this run, it seems that it just took like around 6 minutes, which is weird because like I had thought that it would take longer than that. Let's take a look at why. So if I do kubectl get pods, seems all of them have expired. I'm going to run it again. I want to make sure that it's always actually pulling the image instead of just running the cached one. So I'm going to do kubectl get pods again. I'm going to describe pod test parallelism add 1 and any would do. So seems this one was pulled. Let's try some other. Okay, it seems like this one was pulled as well. Okay, this one was pulled as well, but it seems it's not actually taking a long time to pull. So I'm thinking that it's actually not affecting the speed as much as I thought it would, because the image itself is pretty small. So I'm going to actually let that be. But like if in case you had like big images, this would actually have like a huge impact on your runs. The next thing which we are going to do is we are going to switch to using CeleryExecutor, and we'll take a look at how long does it take to complete the DAG in that case. So going back to the Airflow values file, let's search for executor. Here we go. I'm just going to copy this and I'll change this to be CeleryExecutor. Coming back over here. I'm going to change the apply the Helm upgrade again. As usual, this is going to take a couple of minutes, so I'll pause the video and come back. Now that our Helm install is complete, let's go back to Airflow and okay, the page is not loading. Let me restart the code forwarding. Return to main menu, admin and admin. I'm going to trigger the DAG again to see how it performs under CeleryExecutor. So all of them are scheduled. I'll pause the video again and come back once this DAG is done. I'm guessing it's going to take some time to for this to complete as well. So this time it would be lesser than the Kubernetes executor because Celery would already have all the workers running warm. So it won't need to pay any penalty to stand up any infrastructure or start a container. And here we go, it has already completed. Taking a look at how long did it take, it completed all the tasks in 30 seconds, which is way faster than all the other runs that we have had till now. So if we compare the time, it's in total on CeleryExecutor it took like around 1 minute and 2 seconds, whereas for others it took more than 6 minutes. Now let's compare the results. Using Kubernetes operator and then varying the max task, we saw that the pods were spinning up very quickly, but there was also an overhead with container creation. Forcing image pull actually didn't make much of a difference in our use case because the image was pretty small and the pulling it down actually didn't add a lot of overhead. This was true for our use case, but whenever you have like a huge image, it's always going to be easier to have it cached rather than pulling it on each and every run. When we were using CeleryExecutor, there was no container overhead for each task, and the all the tasks which we had, our example actually zoomed by. All the tasks were sharing worker resources, so concurrency would be limited by worker, CPU, and memory. Depending on your environment, you may prefer the simpler Celery approach or the more pure microservice style of the Kubernetes executor. Some final tips. If you rely on Docker images for each task, consider caching or using, if not present, pull policies to reduce overhead. If you want ephemeral pods for truly separated tasks, Kubernetes Executor is great, but be sure to watch concurrency settings. On the other hand, Celery can be very simple if you don't need strict isolation. In both Kubernetes Executor as well as CeleryExecutor, consider using autoscaling. If you're using Kubernetes Executor, autoscaling would be more on the node itself, whereas when you're using CeleryExecutor, you can use something like Kida, which is an autoscaler for Kubernetes, which can keep an eye out on the Redis queue length and based on which autoscale the workers. That is it for our Airflow execution experiments. We tested dynamically mapped DAGs with 100 tasks, checking out the Kubernetes executor with various concurrency tweaks, forcing image pulls, and then switching to CeleryExecutor. If you found these insights helpful, please like and subscribe and drop any questions below. In the next video, we are taking a detour and going to take a look at using Secrets Manager backend with MWAA local runner with the complete stack running locally. If you're actually trying this out on your local environment, it would be very easy to set everything up because that way you can play around with settings pretty quickly and you don't have to pay anything. Thanks a lot for tuning in and see you soon.